Hello everyone, it's LeetCode, and today we're going to solve the third problem from the green 75 problems. The problem is named Merge to Sorted List. Let's move on to the description and read the description. You're given the heads of two sorted linked lists, list 1 and list 2. Match two lists in a one sorted list. The list should be made by slicing together the nodes of the first two lists. Return the head of the managed linked list. Here you can see an example. Here we have 1, 1, 2, 3 here and 4, 4. So our final linked list should be in order, placed in order. And here in constraints we have very important thing that both list 1 and list 2 are sorted in non-decreasing order. Yeah, let's move to the Xcalibur and I will show you how we can solve this problem. The brute force solution would be just to take 1, 3, 5, 6, 1, 2, 4 and place it into array. After that we should sort it and transform it into our linked list. The time complexity for this solution would be big of n log n, which is kinda big, and the space complexity would be big of n, which is okay, but likely it would be 2n because we should store an array and we should store a new linked list. So let me explain you how we can solve it in more efficient way. First of all, we need to create our dummy node. It would be our head node with the value 0, let's say. It don't matter what the value would be. After that we need to create two pointers to the list 1 and the list 2 node. After that we check if list 1 node is greater or equal than L2. Is yes, so we place our list node here and move this node here. After that we check if which is smaller. Smaller is 1, so we take this value and place it here, and after that we move here. I forgot to tell that we need to have a temporary pointer. It means that we will use it to place to build this third linked list. After that we need to move no, we not need to move. We check which is smaller, and the smaller is 2, so we place 2 here, moving this pointer here, moving this pointer here. After that we check 3 is smaller, then we place 3, moving this pointer here, something like this. After that we see that 4, move this pointer. After that we see that 4 is smaller, then we place 4 here, and we see that our pointer pointing to the nil value. The value is pointing to the nil, so we can if one of them or both of them are pointing to the nil, we can take one that not is nil, and the next node for our temporary node would be this node which is not nil, so it would look like something like 5 and 6. So here's how we can solve this problem, and the time complexity for this would be big O of n because we need iterate only once, and the space complexity would be big O of n as well because we should store this linked list. Okay, let's move on to the code and try to code it up. First of all, we need to create 2 pointers for the list 1 and list 2, var L1 equals L1, var L2 equals L2. After that we should create our head pointer, var let head. Our head is not changing, so we can make it constant, equals list node. After that we should create our temporary node, var temp equals let's make it optional, list node head. After that, we moving through each element for this. We iterating. After that, we iterating while L1 not equals nil and L2 not equals nil. If one of them or both of them is nil, then we will stop iterating. And here is checking if L1 dot value is greater or equal than L2 dot value, then we will temporary dot next equals L2 because it's smaller, L2 is smaller, and the L2 and we should move on the L2 pointer. L2 equals L2 dot next. After that, or not after that, but otherwise, we should do the same with our temporary node, but with the other list. One dot next. Yeah. After that, we should move our temporary node. Okay. At this point, we know that one of them or both of them are nil, so we should figure out how not figure out, we should set the next pointer to the others node, so temp.next equals L1. If it's nil, we will set L2, and we will return head dot next. Let's try to run it. L1 list 1, let's change it, sorry. Temp.next equals L2. Sorry, I forgot to add optional, make it optional. It's okay, so here we go, everything is accepted, let's submit it. And yes, everything is working. We beat 79% of users and 54 with memory. So here's how we can solve this problem. If you enjoyed this video or if you wanna to continue to learn, please subscribe, press like, and share this video with your friends if they are interested in learning algorithms as well. It will help me, and yeah, that's all for today. I will be waiting for you in the next video. Bye.